In the previous video, we have discussed problem on trains. We have learned that if question talk about the length of train, then we consider length of train as part of distance. Okay. In this video, we are going to practice that concept more. So I have a couple of questions for you. Let's solve. So the first question I have here. So I want you to pause this video, look at the question and try to solve by yourself. As I'm sure you must have gone through my previous video, so you are aware about the concept. We are using the length of train as part of distance and also relative speed. Okay, so pause this video, try attempting this question. Okay, let's solve this. So question says a train of length 100 meter crosses another train of 150 meters running on a parallel track in opposite direction in 9 seconds. Okay, so opposite direction, fine. If the speed of train having length 150 meters is 40 km per hour, then what is the speed of the other train in kilometers per hour? Okay, so now what are the things we are going to count in this? First of all, this is question on problem on trains. We have length of train mentioned, so that we are going to consider as part of distance. Whether train run in the opposite direction or trains run in the same direction. In both cases, the length of trains are always added. Okay, so length of train does not depend on the direction. It does not depend on whether the trains are moving in the opposite direction or in same direction. All right, so that's the distance. So what is the distance? What is the distance? I am not going to write a lot of things here because we are in practice sets. Okay, in concept video I have already shown you the drawing and then explained by using that drawing and writing all the steps. Here we'll go direct to the solution. So 100 and 150. So total distance here is 100 plus 150. That will get you what? 250 meters. Now, because the trains are moving in the opposite direction, so we are going to consider relative speed. Okay, relative speed. We are going to consider a relative speed. So relative speed here will be speed 1 plus speed 2, which we need to find out. So let me call it x. Okay, that is kilometer per hour. Okay. As trains are moving in the opposite direction, so relative speed will be x plus y. Remember? Okay. Lecture number 3, relative speed, moving in the opposite direction, plus. Yeah. Okay. Come back. Now, what do we have? We have distance. We got relative. We got. Okay. Now time. Time is given to us as 9 seconds. So first we need to convert this kilometer per hour speed into meter per second. So I should do 40 plus x into 5 by 18. Okay, that will get you meter per second. Now question, should you write all these things in when you're solving the question in exam? Not required. You can directly jump into the formula. The formula is distance is equal to speed into time. So, or you can also say, yeah, okay, so distance is equal to speed into time, or speed equal to distance upon time. You can use either one of them. I'll use this formula for this question. So I have distance to be 250, speed I have 40 plus x into 5 by 18, and the time given there is 9 seconds. Can I cancel this 9 with 18? So 9 ones are 9 twos are 18. All right, now if I cross multiply here, okay, before that, do you mind if I cancel this 5 with this? Do you mind that? Okay, is it confusing? Okay, no problem. Okay, let me take the 5 to the other side and then cancel. It's one of the same thing. So if I have this 250 here, I cross multiply this 5 and 2, take it to the left hand side, denominator will go in the numerator, numerator will go in the denominator, and now I can cancel 5 and 250. 5 5s are 25. Okay, so here I got 5 2s are 10 with 1 0 and 40 plus x. Tell me, what will be the value of x? X will be 60. What did we assume x to be? We assumed x to be the speed of other train. Yeah, we assumed x to be what? Speed of other train. Yeah, then what is the speed in kilometer of the other train? That we have assumed to be x. Okay, that's why we have said relative speed is speed of first plus speed of second. So 40 plus x. Okay, great. Okay, fine. I hope you also got the same answer. So your solution is actually only of this much. Yeah, so you can save time by writing less number of steps. Let's go to the next question. Pause this video, try attempting by yourself. Let's solve this question. So a train 200 meters long is running at the speed of 20 meters per second. How long will it take to cross a bridge for 40 meters length? I know you must be laughing on me that okay, this is a pretty easy question. No conversion of unit, everything is given. Okay, we need to find out the time. So I will say time equal to what? Time equal to distance upon speed. Yeah, but the point is to make you understand how to handle questions where you have length of train given. Okay, consider length of train as part of the distance. So here distance is the length of train plus the length which the distance which the train has to cross. Okay, so length of train plus the distance which train has to travel to cross that. Okay, so 200 plus 400. Now both units are in meters, so we don't need to make any changes there. The speed is also given in meter per second, so we don't have to make any changes there. So if we calculate time this way, you get 600 here by 20. The answer will be what? 30 seconds. Right? Okay. Let's jump to the next question. Here you have a train which is 110 meter long. Again, pause the video, try solving it by yourself. It says a train 110 meters long is running with a speed of 60 kilometers per hour. In what time will it pass a man who is running at 6 kilometers per hour in the opposite direction? In what? In the opposite direction. Keep in mind, opposite direction. So opposite direction, we are going to apply relative speed. Okay, great. Okay, so this is 60 kilometers per hour, this is 6 kilometers per hour, and we are going to apply the relative speed. We need to find out the time. Okay, in what time? So we need to find out the time. Can I jump to the formula directly? Okay, so time equal to distance upon speed. I hope by now you are fine. By now this must be on your tip of tongue. The formula distance, speed, time. Yeah, so time equal to distance upon speed. Now distance, what train has to cover is length of itself, because question does not mention anything else. Question has not mentioned any other length, any other distance, right? So distance is 110 meters. Now speed is 60 kilometer and 6 kilometer. Opposite direction, add both of them. This will become 66. But this 66 is kilometer per hour. So to make it meter per second, we multiply this speed by 5 by 18. Yeah. See, I'm reducing now. I'm reducing the steps. I'm not writing extra steps. Okay. Here you can cancel by 11. 11 1s are 11. 11 6 are 66. Can we cancel by 6 here? Yes. So here we have 6 1s are 6. Okay. 6 3s are 18. Now you know denominator will go into the numerator. Denominator will go into the numerator, right? Great. Okay. Now we can cancel more. We have 5 1s are 5, and here we got 5 2s are 10. So go into the numerator. So 3, and then in numerator you have got only 2. So 2 3s are 6. So it will take 6 seconds. That's your answer. Yeah, I hope it's all going fine. No need to draw the diagram anymore. Okay, even if when we come across any kind of difficult question which we need to understand, see the position of train and the object, we will draw. But these questions are, I hope they are for beginners, level 1. I hope that's going well with you. Yeah, we are going to solve level 2, level 3, but first, as I always say, build your foundation strong, then we will have a lot of shortcuts and difficult questions also. Okay, coming to this question, pause the video, try solving this. Okay, the question says a 180-meter long train crosses another train which is 270 meters opposite direction in 10.8 seconds. If the speed of the first train is 60 kilometers per hour, find the speed of the second train. Easy going. Yeah, let me apply distance is equal to speed into time. This formula, distance is what? Length of train plus length of train. Yeah, so 180 plus 270. Length of train is part of distance. Do you have any other distance mentioned? No. So this is the distance which we need to consider. Speed. All right. So speed here 60 kilometers per hour. And the other train speed we don't know. So let me consider x. So the second speed train that I'm assuming what? X. Okay. Now because that is in kilometer per hour, I multiply by 5 by 18 to convert into meter per second. Why into meter per second? Because distance is given in meters, see, and time is given in seconds, right? Multiply by 10.8, that is time. So distance is equal to speed into time. Okay, fine. Let's move forward. So you got here, you have here 350. Okay, shall we simplify? We can simplify. We want to simplify, you can remove decimal. Here you have got 10. I leave the simplification of this equation up to you. Okay, I know that you guys can do it better. Yeah, okay. So 5 ones are 5 twos are. Here I have 6 threes are, and this can be cancelled. So I got here 6 ones are, and then 6 8s are. So here I got, okay, 6 again. Okay, 18 6 are 108. Yeah, that also we can say. And 2 3s are 6. So nothing left in the denominator. It's only numerator, which is 3. Okay, I'll take 3 to the other side. So I got 60 plus x. Okay, I take this 3 to the other side. So that will go in the denominator. Yeah. All right. Okay, I made the mistake here. This should be 450. Okay, then you got here 15. So x should be 150 minus 60. That will get you 90. Yeah. So speed of the second train should be 90, and that is also in kilometer per hour. Why kilometer per hour? Because we have assumed this x kilometer per hour, right? Okay, I hope this is clear. Calculation, I know you can do things, do it faster. Yeah, let's solve this question. So pause this video, try attempting the question. So what is this question? So question is, a train leaves a station A and reaches station B in 2 hours. First train. Another train, it starts from B and reaches where? A. So both of them are moving in the opposite direction. Let's say this is station A and this is station B. So opposite direction. So the other train starting from B covers the distance in 6 hours. If both trains have started from their respective stations at 7 a.m., both of them are starting together. then at what time do they cross each other? Now I have kept this question intentionally in this particular practice set. Why? For you to understand that every question where you have mention of train, not necessary that you also be having length of train. In every question where you have train, not necessary you will be having length of train also. Not necessary. Okay. And in such question, so that question you should treat it normally, the way you solve this question. Like instead of train, if I say one car and the other car, one bus and the other bus, one truck and the other truck, because length of the object doesn't matter in that particular case. Yeah. So this question, just to make you understand that this type of question is not part of problem on trains. Which type of question do we consider as part of problem on trains? Where you have length of train mentioned. So we consider length of train as part of distance. This question, it has nothing to do with the length of train. I hope this is clear to you. This question has nothing to do with the length of train. Yes? Okay. So we will solve normally, like we will not make a lot of changes or nuisance here. So it will be simple that the only concept which we are going to apply here is relative speed. When two objects are moving in the opposite direction, the relative speed will be x plus y, right? So you have, let's name that to be train A, which is starting from A, and train B, which is starting from B. Okay. Now the time for both of them is given, which they take to cover the distance. Both of them are covering the same distance. A to B, B to A, distance will be same, right? Let me call the distance to be D. Now question said find the time when they cross each other. Okay, so I need to find the time. Do I know the speed? No. Do I know the distance? No. The only thing I know is what? The time in which they cover the distance. Each of them cover the distance. Okay, and distance is common for both of them, right? So I will apply the formula of time, which is distance upon speed. Now here in this case, because two objects are moving in the opposite direction, I will take speed as relative speed. Okay, so distance is d. I assumed the distance between A to B is d, so B to A is also d, of course. Yeah. The time which they take to cover the distance together with the relative speed. Do you know the speed? No. Can we find out can we make the expression of speed? Yes. How? Train A covers the distance in 2 hours, right? So for train A, the speed, for train A, I can say speed will be equal to distance, which is d, by time, which is 2 hours. Here I can say the speed will be distance, which is d, and the time, which is 6 hours, right? So here, if I take the relative speed, that will be speed 1 and speed 2, right? So d by 2 plus d by 6. Okay, so you will get to understand here that I can take d common and cancel. Yeah, I can take d common from the denominator and cancel with the numerator. So what do I have here? What do I have here? I have 1 upon 2 plus 1 upon 6. So d is gone, no other variable. Can we find the answer here? Can we find this? Simplify and find the answer. Simplify. So what do you get here? 2 plus, or let me take the LCM to be 6. Okay, here 1. So this is what? 3 plus 1, 4. Yeah, denominator will go into the numerator. So you've got 6 by 4 like this. Yeah, 6 by 4, which will get you what? 1.5. Okay, and time, this 2 and 6 was in hours. The unit of time here is hours. So this will be 1.5 hours. Well, is this the answer? No. Question said at what time will they cross? When, if they start at 7 a.m. So here we'll say they will cross after 1.5 hours. So what is the time after 1.5 hours when you start from their place, when they start from their place at 7 o'clock? So 7 plus 1.5 is what? 8.5. 8.5, or in terms of time, I can say 8 hours. Okay, 8 hours, 30 minutes, right? 8:30 a.m. After 7 a.m., if you count 1.5 hours, it will be 8:30 a.m. Right? Okay, so I hope you like these questions. Some of them were easy questions, and this question is unique. Yeah, this was necessary to be part of this practice set so that you understand that not every train question should have something to do with the length of train. Okay, so well, this is it in today's video. I will see you in the next lecture. In the next lecture, we are going to discuss about the straight race. Okay, when A beats B, A beats B, or A gives a head start to B. So these kind of questions, right? So this is it in today's video. My name is Shyam Manawat. I will see you in the next lecture. Till then, stay happy, stay healthy. Bye bye.